Hi everybody, this is your last video on triangle congruence. So I'm going to do a couple more proofs, a couple more practice problems for you with these triangle congruence criteria. So let's go ahead and jump into it here. Okay, so in this first one, I have some given information, which is already marked very nicely for me on the diagram. Okay, so I have angle L is congruent to angle N, so marked here in, let me erase that. Okay, so it's this one. It's kind of marked in purple here. Okay, and then they also said that angle LOM is congruent to angle NMO, which is this one with the double congruence marks here. Okay, so very nicely here, I already have two angles, an angle and an angle, so I just need a side, right? And lucky for me, these two triangles share a side right here, side MO, okay? So there's my three criteria, right? I have my three things. I have two angles and a side, okay? So that's how I'm going to prove that these triangles are congruent, okay? So I've kind of made myself a roadmap. I kind of know where I'm going. So now I'm going to go and write in my given information. So I have angle L is congruent to angle N. And the reason for that is given to me. That is some given information, right? And that's my first angle that I have right there, okay? Second piece of given information was angle LOM is congruent to angle NMO, right? And that was given. That's my second angle. And then my third thing here was my side, right? And so that is side MO is congruent to itself. Okay, and whenever something is congruent to itself, that reason is always the reflexive property. Okay, so now I have two angles and a side that is not trapped in between them. Okay, so a side that's just kind of off to the side. So I have enough info now to say that these two triangles are congruent, right? And the reason I'm going to give is the triangle congruence criteria that it fits, angle, angle, side. Now, I want you to notice that I wrote them out here on the side. I mostly do that for you all so that you can see where the angles and the sides come from. When you are writing proofs, you don't have to do this on the side. You can if you want to, if it's something that is helpful to you, but it's not something you have to do, okay? All right, so we've got another one that's kind of partially filled in here for you, and we are dealing with a midpoint, right? And we have some sides that are marked as congruent. Okay, so I want you to give this one a try, and then we will see how you did. So pause the video, give this one a try, and then come back and check your answer. All right, folks, so go ahead and check your answers against mine here. So again, very conveniently, in the given information, they already gave us two sides. So they gave us PS is congruent to QT, and they gave us that QS is congruent to RT. So those are two sides that I already knew. So this one marked in green, and this one marked in blue right here. So then the last thing I had to figure out was, okay, I either need one more angle or one more side. And there's one piece of given information that I hadn't used yet, that Q was the midpoint of PR. So this phrase right here, okay? So if Q is the midpoint of PR, then that means that the two parts are congruent. Okay, that's what a midpoint is. It's a definition of a midpoint. So I marked those with my congruence markers, and I have my third side. Okay, so when I'm writing this out in a proof, though, I can't immediately jump to, oh, PQ is congruent to QR, right? I have to indicate how I knew that first. So I have to write in that Q is the midpoint of PR as the given information, right? And then we used that information to justify why PQ was congruent to QR. right? So we used it as a reason. They just wrote midpoint right here. You could write definition of midpoint. If you wanted, but this is perfectly fine. So now I have three sides, S, S, S. So these two triangles are congruent by side, side, side. All right. So I've got one more proof for you that has like one extra step. It's a little bit longer than these two. So give me just a second to kind of rearrange, clear my screen off, and then we'll do that last proof. All right, folks, so last proof here. This one is a little bit more involved. There's a little bit more like deductive reasoning that you have to use. There's a couple more steps that we have to use in order to completely write this proof, okay? But as always, we're going to start with the information that we know and mark the diagram and make ourselves a roadmap. So the first thing that I know is that PQ is parallel to SR. Okay, so I'm going to mark that with my little arrows that show that those are parallel. So what I'm hoping that you notice is that you have right here two parallel lines cut by, oops, hold on. I'm going to do this in a different spot here. You have two parallel lines cut by a transversal. So all of our angle relationships are going to hold here. Okay, so that's going to give us some helpful information. Okay, the only other thing that they said was that PQ is congruent to SR. Okay, so I'm going to mark these with a little dash, okay, so that I know that those are congruent to each other. All right. So right now in my diagram, I only have that one side is, I only have one set of corresponding sides, corresponding congruent sides. Okay, and I want you to take a look. My end goal is to prove not that the triangles are congruent, but that parts, a set of corresponding sides in the triangle, in those triangles are congruent. So that means we have to show that the triangles are congruent first. Then we can say that all of their individual parts set and their individual sets of corresponding sides are congruent. Okay, so the easiest thing for me to mark on this diagram that can give me another side or another angle is this right here, this side that they have in common. Okay, so now I know, okay, I either need another side or I need another angle. Since I'm trying to prove that this side PS and this side QR are congruent, I can't really use those. Okay, so I need another angle, right? But the one thing that I have not used yet, the one thing I haven't used yet in my diagram is this, right? I know that those two lines are parallel, okay? If you kind of take this shape, right, and write it out a little differently. So say here's PQ, okay, and here's SR, okay, we have this transversal that's cutting through them, okay? So keep in mind, right, and we have to remember that, oh, I have some angle relationships that I can deal with here. I have this angle and this angle. Those are alternate interior angles, and they have to be congruent, okay? So now I have enough information to say that my triangles are congruent, okay? So let's go ahead and write this out, okay? So I'm going to start always with my given information. So PQ, oops, hold on guys, I'm getting a bunch of text messages, sorry. Okay, so PQ is parallel to SR, okay, and I really should, I should draw my little lines over the top here. My goodness. I really am getting a lot of text messages, y'all. Sorry about that. Okay, so I have PQ is parallel to SR. Okay, and then sorry, it's not allowing me to write this in the way that I want to. Hold on. There we go. Okay, so, and I can also say PQ, I'm going to leave a little bit of space because I'm going to have to draw that in, is congruent to SR. Okay, PQ is congruent to SR. Right, and my reason for both of those is that that was given to me. So that's given information. Given. Okay. And what I have, okay, what I have from that is I have one side, okay, which is good. All right. I'm going to deal with my angle next, right? The angle that I marked is congruent. Okay, so I would say angle PQS is congruent to angle RSQ. Okay, and my reason is that alternate interior angles are congruent. Okay, so now I have an angle. Okay, and then my last, okay, then my last set here, my last side would be QS is congruent to itself. Right, QS is congruent to QS. Remember, always the reason for that, whenever things are congruent to themselves, that's always the reflexive property. Okay, so now I have side, angle, side. Okay, so now I can say that the triangles are congruent. So I can say triangle PQS is congruent to triangle RSQ. Okay. I'm sorry, I'm having to write this in little stages with what I have to draw versus what I can type. So triangle PQS is congruent to triangle RSQ. Okay, and my reason for that is my triangle congruence criteria. So those are congruent by SAS. But then I have to go back and say, okay, what is my actual thing that I am trying to prove? And that thing that I'm trying to prove is that PS, this side here, is congruent to QR or RQ, which is this side right here. Okay. But now I have the ability to do that. I can say that those are congruent because they are corresponding parts of congruent triangles. So I can say PS is congruent to RQ. Okay. And the reason I can say that is because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, you don't have to write out the whole thing. I just typically do just so that you all can see what I'm doing, but you could just write CPCTC. Okay, so what I went through and did in this proof, just to recap, was I went and figured out that the triangles were congruent first. And then after I was able to figure out that the triangles are congruent, I could break the parts down and say that the individual sets of corresponding sides and angles were also congruent. All right, so that is it for this practice problems video. Please reach out to me if you are struggling a little bit with proofs. I know they can be kind of tricky. It's definitely one of the trickiest parts of geometry. So please reach out if you need assistance. All right. And I will see you all in the next video. Bye, everybody.